Hello everyone, welcome to Scalecraft. Your app is slow. You upgrade the server by 10x the bandwidth and it's still slow. Why? Because you fixed the wrong thing. Most engineers, even senior ones, confuse latency, throughput, and bandwidth. They sound the same. They are not. And mixing them up means throwing money at a problem that won't get better. So in the next few minutes, I'm going to show you the difference using a highway, a formula, and some real numbers that will make your operations team sweat. Imagine a highway. Latency is how long it takes a single car to drive from one end to the other. Pure travel time, nothing else. Bandwidth is how many lanes highway has. More lanes means more cars can travel side by side, but it does not make each car go faster. And throughput. That's how many cars pass a checkpoint per minute. It depends on both the road width and the car speed. So, here's the formula that ties them together. Throughput is equals to concrete users divided by latency. So, this is not intuitive, it's everything. If your latency doubles, your throughput will halve, even if you haven't changed a single lane on that highway. Now, here's where people go wrong. They see bad performance, they assume the highway is too narrow. They throw money at bandwidth, more lanes, bigger pipes, better network cards, and nothing gets faster. Because bandwidth is the maximum possible. It's theoretical. Throughput is what you actually get in the real world. And throughput is always less than the bandwidth because latency is always fighting it. Let's zoom into latency because it has different layers. So when a request hit a server, the clock does not start at your code. It starts way before that. Physical time taken by your request between cables and routes. DNS lookup, your server's phone book lookup. TCP handshake, the digital how can we talk between client and server. Then your actual server processing time and also the DB query time. Each of this adds latency and this stack. So how do you measure it? Not with averages. This is liar. You want percentiles. P50, P95, P99. P50 means 50% of your requests are faster than this number. That's your median user. P95 means 95% of requests are faster. 1 in 20 users is slower, let's say. And P99, 1 in 100 user is having a bad time. And in production with millions of requests, that's a lot of people. So here's the rule. In production, you ignore P50. It's median. You watch P95 and P99 because your worst users are your most vocal users, right? And they are the ones that once writing the one-star reviews. So how do you actually reduce the latency? Cache aggressively, right? If you have already computed something, don't compute it again. Move compute closer to the users, like CDNs. Don't just serve static files, they shrink the physical distance the data has to travel. Index your databases. A slow query is often the missing index. This one's embarrassingly common. Connection pooling. Don't open a new database connection for every request. Reuse them. Opening connection is expensive. And finally, send multiple requests over a single connection. HTTP does this for you. It's called multiplexing and it kills you ton of unnecessary overhead. Believe me. But there are some myths that we need to bust. More bandwidth does not mean lower latency. No bandwidth is capacity. Latency is the travel time. So a 10-lane highway does not make your car go faster, right? Low latency is not equal to high throughput. Not automatically. Throughput depends on parallelism, right? A single threaded server might respond in 1 millisecond, but if it can only handle one request at a time, your throughput is still terrible. High throughput is not equal to fast system. Your server can process 1 lakh requests per second. Congrats. It's like each one takes 3 seconds. The humans using it are suffering. And the most important one, like bandwidth is not always the bottleneck. Check your CPU, check your database, or maybe a poorly written code. Adding network capacity does zero for those problems. So, how do you actually improve the throughput? Do horizontal scaling, do read replicas, add the load balancers. It's like distribute your traffic intelligently across your feed. Or you use event-driven architecture. So like instead of blocking threads, right? Allow asynchronous input-output to handle more requests simultaneously. Or maybe you use message queues. Like if you can't process it, now queue it. Decouple the ingestion from processing. So what about the bandwidth? Here's where is actually the bottleneck. When you're moving the large data, like in case of video streaming, or you are training your ML jobs, or you are doing some backups or some bulk data upload, let's say, in those cases, upgrade the pipe, compress your payloads, or maybe use a CDN to transfer the data. Now, this is a decision tree that you have to use. If a human is waiting, optimize the latency. If a machine is processing in bulk, you need to optimize the throughput. And if a large data needs to flow, that's where you use to optimize bandwidth. That's it. That's the decision tree. Your user is clicking a button and staring at a spinner. That's latency problem. Fix the database query, add a cache, do not touch the bandwidth. Your data pipeline is crunching logs overnight. That's throughput problem. Add the workers. So your video platform is buffering. That's a bandwidth problem. Compress them. Use CDN. Bigger pipes. Right? Most performance disasters happen because someone ran the wrong playbook on the right problem. Now you have to know which one to run. So if this cleared up a concept that your test books make confusing, drop a comment. Tell me what system design topic you want me to break down in the next video. And if your colleague still thinks just increase the bandwidth, fixes everything, send them this video. Do it for the P99 users, right? They deserve better. Thank you.